Question 5 of the revision exercises. Two masses 10 and 4 are connected by a string which pass over the smooth pulley. Again, you know what you're dealing with. And the string is 5 meters long. So we have this triangle here. It's trying to give us the angle. They don't give us the angle this time. The heavier mass starts from rest at the foot of the plane. So the 10 is here. 4 is here. You'd imagine the 4 will go up, but this question is telling us the 4 hits the ground. And find the common A, acceleration, 4 hits the ground, the speed at which it does, and how much further 10 will travel up the plane after the 4 kilo has hit the ground. Okay, let's work out sine A. It's equal to 1 over 5 O over H. And this would mean that the adjacent side is the square root of 5 squared minus 1 squared, which is equal to root 24. So cos A will be equal to A over H root 24 over 5. So let's have a look at our diagram. We have the 10 kilo mass. We don't need to put it exactly where it is on the diagram, but we can move it up a little bit just for ease of drawing. So we have our A, we have mg, we have another A, we have mg cos A here, which is equal to 10g by root 24 over 5. Now root 24 does simplify, doesn't it? Root 4 by root 6, 2 root 6. May as well do it in its simplest form. So that's equal to 2g by 2 root 6. So it's going to give a 2g and a 2 root 6 of 4 root 6g. And that's in that direction. And then parallel to the plane, we have mg sine A, which is 10g by 1 over 5, which is equal to 2g. So we have tension in the string for 10. It's going up. So we have T. We got mu here. Any mu? Smooth inclined plane, so we don't have any mu. So T minus this mg sine A, 2g, is equal to ma, 10a. And then if we do the 4 kilo here, 4 kilo tension, 4g, A is going down. So I'll write this equation underneath. 4g minus T is equal to ma, 4a. So combining these two equations, we're going to get 2g is equal to 14a. So A is equal to 2g over 14, which is equal to g over 7 ms to the minus 2, and 9.8 divided by 7, that would be 1.4 ms to the minus 2. So that's the common acceleration, the speed with which the 4 kilo mass hits the ground. So just remind yourself, it's 1 meter. They're saying it's, did they say it's exactly 1 meter? The two masses 1 meter high, yeah, so it's at the top. So we're assuming the S is 1 meter here. No other information. A is 1.4. It starts from rest. We have V is equal to, we're looking for V, the speed at which it hits the ground. We get it from V squared is equal to U squared plus 2AS, yep. So V squared is equal to U is equal to 0 plus twice 1.4 times S, it's 1 meter high. So V squared is equal to 2.8. And V is equal to the square root of 2.8. Which gives root 70 over 5, 1.6733. I'll write it as equal to root 70 over 5, 1.6733. Does it ask for, no decimals, 1.6733. I'll take 4 decimals, meters per second. And how much further? So this speed is going to transfer to 10. So how much further will it travel up the plane? So its velocity is going to come to 0 for 10. Its initial speed, I'll use root 70 over 5 just because it's more accurate. And we're asked for s, how much further it will travel up the plane. So if we look at 10, it's going up in this direction. What's opposing it going up? This will be my acceleration, this mg sine a, which we got to be 2g. So it's going to be opposing, it's going to be slowing it down, so minus 2g will be equal to a. So VUAS, same equation, v squared is equal to u squared plus 2as. So we have 0 is equal to root 70 over 5 to be squared, which will be 70 over 25, plus twice minus 2 twice a, so a is minus 19.6 minus 19.6 times s. So we're going to get 39.2s, bringing it to the left, or just use a calculator, is equal to 70 over 25. So s is equal to 70 over 25 times 39.2, so not too far. S is equal to, that works out to be 0.0714285. Just take 14, so this is in meters, so it looks like about 7.14 centimeters. I know I think the answer in the book has 70 centimeters, but I'm pretty sure that 7 is correct.